Day 102 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. You know how we do. And this time we're at day 102, y'all. We've officially been doing LeetCode problem every day for 102 days straight, y'all. No breaks, no getting tired, no complaining. We're just doing it. We're staying disciplined, and we're going to keep going. I don't see an end in sight, y'all. But before we get started, don't forget. Bring your mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. This is not a drill. I need you to drop 2 bank emojis in the comment section so we can run this engagement up and help get this content out to a broader audience and help get more people interested in Swift so we can do our part in building the Swift community, y'all. Now, with all that being said, I know why you're here. And today we have question number 2824. Count pairs whose sum is less than the target. The difficulty level is easy, guys, so you already know we're going to keep the solution as simple and easy to understand as well, because we're all trying to learn here, and there's no point in writing code that nobody understands, because then nobody's going to learn and it's just going to be a waste of a LeetCode problem. So before we understand the code, the first thing we need to do is understand the question. So let's get to it. The question says, given a zero index integer array nums of length n and an integer target, return the number of pairs ij where 0 is less than or equal to I is less than j, and j is less than n, and nums I plus nums j is less than target. So let's break that down. Look at these examples so we can really see what they're talking about. So first we have an input nums. The nums is -1, 1. It's an array of integers, which are -1, 1, 2, 3, and 1. The target is 2. The output is 3 because the explanation says there are 3 pairs of indices that satisfy the condition in the statement. So the condition that needs to be satisfied is I has to be less than j, or 0 has, let's start from 0 has to be less than or equal to I has to be less than j, and j has to be less than n, and nums I plus nums j has to be less than the target, right? So let's look at these 3 pairs of indices that they say are the only ones that satisfy the conditions in the statement. So first, we have indices 0 and 1. So let's look at indices 0 and 1. Indices 0 and 1 is -1 and 1. When you add -1 to 1, that equals 0. 0 is less than 2, so that satisfies the conditions of the statement. 0 and 1, -1 plus 1 equals 0, and that's less than the target, which is 2. So let's look at the next one. Indices 0 and indices 2. Indices 0 is -1. Indices 2 is 2. -1 plus 2 equals 1, and that is also less than 2. So that satisfies the conditions of the statement. So we can add that to our count. If we're keeping count, now we have 2 pairs of indices that satisfy the statement. Now the third and last one, 0 and 4. So let's look at index 0 is -1. Index 4 is 1. That's going to give us -1 plus 1 is going to give us 0, which is less than 2, so it satisfies the conditions of the statement. Note that 0 and 3 is not counted, since nums 0 plus nums 3 is not strictly less than the target. So if we look at nums 0, that's -1, and we look at nums 3, that's 3. That'll give us -1 plus 3 equals 2, right? So 2 is not less than 2, it's equal to 2. We're looking for things that are, excuse me, y'all. We're looking for indices that are strictly less than the target. And since that's equal, that means it's not less than the target because it's equal. So we don't count that in when we return our integer or return our count that we want. So those are the 3 integers. If you look, no other pairs will be less than 2, because if we move down to integer 1 and do the same thing, we already did that pair. We already did 0 and 1, so we don't have to do that. 1 plus 2 is 3. that's greater than 2. 1 plus 3 is 4, that's greater than 2. And 1 plus 1 is 2, that's equal to the 2, so they don't count. Then we could do the same thing. We already did it out. We already did 1 and 2, so we do 2 plus 3, that's 5, and 2 plus 4 will give us 3. So both of those are greater than 2, and then so on. If we did the 3 plus 1, that's going to give us 4. That's greater than 2. So that's why these are the only 3 indices that we can add together where they will be less than the target. So let's look at example 2 to really bring this home. It's more numbers, but it's not that hard. Let's just go through it just because why not, y'all? Just to make it make sense for everybody. So we have the input nums. It's an array of integers: -6, 2, 5, -2, -7, -1, and 3. The target is -2. So apparently there are 10 pairs that we can use. There are 10 pairs of indices that satisfy the conditions of the statement. So let's look at the 10 pairs. We have 0 and 1. You do index 0 plus index 1. -6 plus 2 is going to give us -4. That's less than -2. So that's one pair right there. Then we have 0 and indices 0 and 3. So we have -6. And then we have 0, 1, 2, 3. So -6 plus -2, that's going to give us -8, which is less than -2. Then we have indices 0 and 4. So we have -6, and then we have 1, 2, 3, 4. So -6 plus -7, that's going to give us -13, and that's less than 2. Then we have indices 0 and 5. So we have -6, then we have 1, 2, 3, 4, 5. -6 plus -1 is going to give us -7. -7 is less than -2. Then we have 0 and 6. So we have -6. Then we come over 1, 2, 3, 4, 5, 6. -6 plus 3 is going to give us -3. -3 is less than our target, which is -2. Then we have indices 1 and 4. Then so 2 plus then we go 1, 2, 3, 4. 2 plus -7 is going to give us -5. That's less than -2. Then we have indices 3 and 4. So we have 0, 1, 2, 3. We have -2 plus -7. That's going to give us -9, which is less than -2, and so on and so on, y'all. Y'all get the point now. Y'all can look at these examples and look for yourself. But now that we understand the question, y'all, let's get into the code. The code is not that difficult. We've actually done problems like this before. So let's get started, y'all. The first thing we are going to do is declare a variable called count. And that's going to keep count of all of our pairs. We're going to set that equal to 0. Then we're going to come down here and we are going to say for I and 0 up to nums dot count. What we are going to do, then we are going to open up the brackets. We're going to come down here. We're going to do the same thing for j. So we're going to say for j, and this time we're going to say I plus 1, because j is going to be 1 more than I basically as we loop through it. So if indices 0 is I and j is I plus 1, that means j will be indice 1. If indice I is 0, if I is indice 0 and j is indice I plus 1, that will make j indice 1. You see what I'm saying? So then we're going to do that. We're going to come over, we're going to say I plus 1 up to nums.count. Then we're going to come over here. We're going to say if nums I plus nums j is less than target, then what we are going to do is we are going to say count plus equals 1. So that's just going to count all of the pairs that where nums I plus nums j is less than target. Then we're going to come down here and we're just going to say return count, y'all. And that should be all she wrote. Let's run it and see how it runs. Should run well, y'all. And it's accepted, y'all. First try. So let's submit it and see what that time is looking like, y'all. Let's see. And there it is. 10 milliseconds beats 41.27% of users with Swift, y'all. Not too shabby at all. Remember, we're trying to keep the solution as simple and easy to understand as possible. And I think this is a good foundation to build off as we go on further down our LeetCode journey. So get one more look at the code, y'all. One more look at the code. And I will see y'all tomorrow for another day, another LeetCode problem. Peace.